All right, ladies and gentlemen, I just wanted to recover a couple of examples from today in case you needed to hear it again as you are working on your homework. Remember, we're talking about our radicals. We are only talking about square roots. So when you have your index of 2, that means you are looking for pairs of numbers. So one of them can come out from underneath the radical. We talked about what some perfect squares were. And what's important about the perfect square is if what's underneath the radical is a perfect square, your radical is going to go away because there will be nothing left to remain under it. For example, 16 is a perfect square. It's made up of 4 times 4. That is a pair of 4s. That means one single 4 comes out. But there's nothing left to remain underneath the radical, so your answer is 4. Over on example number 2, 121 is a perfect square. It's 11 times 11. What's different about this one is it had a number in front of the radical. Anything that's going to be pulled out gets multiplied together to what's already in front. So 121 is 11 times 11. That's a pair. A single 11 will come out and it's going to multiply to what's already there. So your answer here will be 22. Okay. To get 289, 17 times 17. You have a pair of the same number, so a single one comes out. 17 times 6. That's going to be 102. 400 is 20 times 20. We have a pair of 20s. That means a single one comes out. There's nothing left to remain under the radical. 20 times 3 is 60. So in each of these cases, the radical went away because the number underneath the radical was a perfect square. But what happens if it isn't a perfect square? That's these examples down here. Now we did ours a little bit different than these steps, and that's just fine. So what we were doing is we were looking for how can we begin to break this down. So if this is not a perfect square, 32 is not a perfect square, you will have a radical in your answer. The radical will not go away. So let's start breaking it down. Today in class, somebody had suggested 2 times 16. Any factors will do that actually multiply to 32. The 2 is a prime number. It will not break down again, but 16 will break down to 4 times 4. Since I rewrote 16 as 4 times 4, I'm going to cross that off so I'm not looking at it anymore. When I did that, I noticed that I had a pair of 4s. Anytime you have 2 of the same number, you can bring one outside. Okay, so we've dealt with this there, but there's this 2 right here. It does not have a pair, so that means it's going to have to stay underneath the radical. So when I draw my radical, it's going to have a 2 underneath and a single 4 on the outside because there was nothing else out front to multiply it to. Let's try example 6. 180. I had it suggested to me in class of 18 times 10. All of this breaks down, so we want to keep breaking it down until we get to some prime numbers. 10 can be rewritten as 2 times 5. So I'm going to cross the 10 off so I don't see it anymore. 18 is 2 times 9. I rewrote the 18, so cross them off. 2 is prime, it will not break down. 9 actually breaks down again to 3 times 3, so I'm going to cross this guy off. This 2 is prime and the 5 is prime. So we got kind of a lot of stuff going on here. Let's look at this. I have a pair of 3s. That means one 3 is going to come out front. Look here, I have a pair of 2s. So I got to bring the 2 out also. But this 5 is going to remain inside because 180 is not a perfect square. So my radical, the unpaired one, stays underneath. I took out a 2 and a 3, so we multiply them together to get 6. All right, let's try problem 7. We determined that it was divisible by 3 And if we multiplied 3 times 49, we would get 147. 3 is a prime number, so it can't break it down any further, but 49 can be rewritten as 7 times 7. So I'm going to cross off the 49 so I'm not looking at them. I have my pair of 7s right here. That means one single one will come out. The 3 is not part of a pair, so it's going to remain under the radical. So the 3 stays in and the 7 will come into the front. Okay. Number 8, 175. We knew immediately 5 would be a factor of it. So if you take 5 times 35, you'll get 175. 5 is prime and will not break down again. 35 can be rewritten as 7 times 5. I'm going to cross this one out so I don't use it. I have a pair of 5s. That means 1 comes out. This 7 didn't have anybody to pair with, so it remains under the radical. So there's a 7 under the radical and a 5 on the outside. 9 is pretty much the same, so I'm just going to skip to 10 to look at it because it is a little bit different. 54, in class we came up with 2 times 27 is 54. 2 is prime and will not break down again. The 27 can be written as 3 times 9. I'm going to cross out the 27. 3 is prime, it will not break down, but 9 breaks down one more time to 3 times 3. So I have a pair of 3s here. So that means 1 comes out. It's going to multiply to what's already there eventually. I have another 3 and I have another 2. Neither one of those have pairs, so they're going to have to go under the radical. Anything, if you have more than one number going back in, you just remultiply them back together. So that's 2 times 3, so we're going to have a 6 under the radical. And out front we have 3 times 2, which is also a 6. Hopefully this will help you if you get stuck with any of the homework tonight. And I'll see you in class tomorrow. Good night.